Hello, chemistry students. I wanted to continue our work on the mole today, even though I'm not with you. So we're going to be looking at part 4, the mole in terms of volume. And this begins on page 4 of your packet. So please turn to page 4. And what I'm going to have you do is have you pause the video and have our teacher read out loud to you the information from pages 4 and the top of page 5. And then you're going to restart the video when you're ready to work through the practice problems in the middle of page 5. So please pause the video now, and I will see you in a minute. Okay, welcome back. And hopefully from your reading, you got that 22.4 liters of a gas is equal to 1 mole of that gas. And we're going to use that information in some practice problems here, always starting by writing down what is given to us. So in example problem number 1, I have 34.3 liters of a sample. And I need to choose the conversion factor that's going to change this from liters, which is volume, to moles. And that means, because we've started with liters, we have this unit right here, we're going to place liters on the bottom so that that would cancel out when we do our math. So the 22.4 liters is going to go on the bottom, and 1 mole is going to go on the top. And when we perform these calculations, we will see that the answer is 1.53 moles. Make sure that you are remembering to label the substance all the way through, which I will continue to do unless I run out of space on the board. For sample problem number 2, what I'd really like is if you could pause the video and please try this on your own, and then turn the video back on and we'll check our answers together. All right, welcome back. I'm going to start by writing down what I'm given in the problem. And this is water vapor. When you see the word vapor there, it means in the gas state. And to choose my conversion factor, because I'm starting with liters, I'm going to want liters on the bottom of the equation and 1 mole on the top. Oh, and I did it. I was trying to label it. There we go. Water, not nitrogen. And again, because the 22.4 is on the bottom of the fraction, you're going to divide by it. So when I type this in my calculator, I'll type 12.5 divided by 22.4 liters of water vapor. And my answer is 0.56 moles of H2O. And that's not to significant figures, but as I asked you yesterday in class, keeping 2 digits after the decimal for the majority of these problems will just make our lives easier. All right, so in these examples for number 3 and 4, we're going to begin with moles and end with liters. So we'll start by writing down what we know. And because we have moles as our first unit, we're going to want moles to be on the bottom so that it will cancel out. And we remember that 1 mole of gas is equal to 22.4 liters of that gas. And because 22.4 is on the top of the fraction this time, we're going to multiply. So 3.40 times 22.4. And when you type this into your calculator, you will get 76.16 liters of chlorine gas. All right, please pause the video and try problem number 4 on your own. Answer to number 4, 0.98 moles of neon gas. Again, because we have moles as our initial unit, we want moles on the bottom, and then our value of 22.4 liters on the top. So we would multiply 0.98 times 22.4, and my final answer is 21.95. All right, so now we've gone over multiple types of mole conversion problems, and we are going to put them all together. So before we do that, this is section 5 on page 6 of your packet. But before we jump into finding the answers, I would like to quickly review how to use the scientific notation on your calculator. So here's a picture of your calculator, and don't forget, or those of you that were absent last Friday, 6.02 times 10 to the 23rd is the same thing as 6.02 E23 in your calculator. And you can get that function on your calculator by using this little EE button right there. And to get to that, you're going to have to hit the second key since it is one of the blue features. So hit the second button and then EE. This E pops up and it means times 10. So that's how you're going to use that feature in the calculator to do your mole particle conversions. All right. So as we're looking at these practice problems, one of the things I would like you to do is look and see in your packet, where can you find help? So I've written some page numbers here for problems 1 through 4. You could look to page 4 for help on number 1, page 2 for problem number 2. And as you do this, this is one of the reasons that I made this packet for you for stoichiometry. You can always refer back and find some practice problems that will help you with setup. So hopefully you've taken the time to either write those down or you can look it up for yourself. And then for the second half, there's questions 5 through 8. So those are the page numbers you could refer back to if you feel like you need help with setup on those problems. So right now, I'm going to have you pause the video and you need to complete all 8 problems. This might take you a little while, but help each other, work your way through. For some of them, you're going to need the periodic table. You're definitely going to need that 6.02 times 10 to the 23rd Avogadro's number. And if it's about volume, you're going to need that 22.4 liters equals 1 mole conversion. So pause the video, answer the questions, and when you're finished, unpause, and the answers will be on the screen available for you. So here are the answers to problems 1 through 4. Please make sure that you are labeling everything correctly so that you can keep track of things once we start doing 3-step problems instead of 1-step problems. So pause the video now and check your answers to questions 1 through 4. All right, here are the answers to questions 5 through 8. Again, try to be careful about labeling. I know in the small space that I've given you, it's challenging to be able to write the word molecules, but do the best that you can to try to keep everything labeled really well. If you're picky about it now, it will really help you later. Right, that is the end of our video, and I hope that you were able to work through these mixed up problems together today pretty well. When I return on Thursday, we will be going over a couple of practice problems together, and then we will begin mole-mole ratios and our next lab.